Hi, and welcome to Honeycomb's Big Data series on security intelligence. In this part 1 of the series, I'll be showing you how you can utilize large amounts of arbitrary data for security and operational intelligence, and give that data context and meaning. In part 2 of the series, we'll show you how this data can then be seamlessly integrated into QRadar and third-party SIM products. So let's get started. One of the problems we all face with big business data is that it's all over the place. It's everywhere. Some of it's in the cloud, some of it's on servers in different locations. So getting hold of that data is a real challenge, and that's where Lexicon comes in, to be able to gather all that data and make sense of it regardless of where it came from or what format it was originally in. Lexicon can, and typically does, take live feeds from syslog servers and log files and Windows servers, file integrity monitoring, and all your arbitrary data. And Honeycomb has a suite of technologies to handle data collection across huge infrastructures. And in this series on big data security intelligence, I'm going to concentrate on offline arbitrary data. It could just as easily be live data, but I'm going to show here arbitrary log files and different kinds of documents and all sorts of very messy data that we're going to very quickly and easily make sense of. So I'm going to copy all of this arbitrary data into this Lexicon monitored folder. Now by default, Lexicon automatically monitors the auto folder here, but you can configure it to be any folder, any number of folders, including remote UNC paths, so that you can monitor data automatically and remotely and across multiple systems. So I'll just go ahead and copy these files across, and as soon as they're copied in, Lexicon begins processing them, classifying them, and indexing them. So I now switch over to Lexicon's default dashboard. As you can see, we've got a fresh installation here, and this dashboard will show the data that is stored in Lexicon, and it can be across 1 server, 2 servers, 10 servers, 1,000 servers. So you can see we've now populated the Lexicon index with about 2 million events from that arbitrary data. Now, 2 million events is typical for the amount of files that we copied over, but Lexicon's distributed nature means that you can scale that up to hundreds of millions and billions of events. So we can see here that Lexicon has processed this data and classified it under different types like DNS and ASA and F5, Juniper, as well as extracting host names and retaining timestamps, and overall making sense of this data. So now we can start focusing in on the detail of these events. For example, I can click on the iron port data and it will filter out everything else except for the iron port events. If I want to go back, I simply press the back button and I'm back to where I was. One of the great advantages of Lexicon is being able to search intrinsically across all of these different types. So for example, if I put my name in here, it will find all the occurrences of my name across all of those events. You can also use Lexicon's big data catalog to find out generic things across all of the data. For example, I can look for things that are bad, so things that contain the word error or fatal. Honeycomb also includes a comprehensive set of reporting tools, automated and scheduled, and you can also export anything you see on the screen to a PDF with just a few clicks. So you can share the data with your colleagues, and it's that quick to generate a PDF file. There are of course many other advanced features to Honeycomb Lexicon, and in this part 1 of the series I've shown just how easy it is to bring in lots and lots of data and be able to view that data and give it some context very quickly and very easily. Lexicon's integration with QRadar can be divided into 3 distinct parts: data forwarding plus filtering, file integrity monitoring, and Lexicon's integration with QRadar's console. Lexicon's data forwarding allows you to send data from Lexicon directly to QRadar, including data that has been indexed in formats that QRadar wouldn't normally recognize. Forwarded data can also be filtered, so you choose which data you want QRadar to receive. You can also optionally reformat some of that data in case some of it is in a raw, unnormalized format. One of Honeycomb's flagship products is a world-class real-time file integrity monitor, which plugs in natively to all QRadar version 7.2 and above, so send FIM data to QRadar and it will automatically recognize it. Honeycomb's partnership with IBM allows Lexicon to include deep integration with QRadar's console, giving you the opportunity to quickly and easily view event data that may surround an event or an offense within QRadar, and even related raw data like we talked about in part 1 that might not even be in QRadar because of its format or its semantics. So looking at the QRadar console, we can right click on an event or an offense or a group of events and deep dive into more related data concerning that. So here we're looking at an IP address and we click on the Lexicon event integration, and that launches the Lexicon browser with the related data concerning that particular event. So we can see that there's a threat event there, so we can click on that event and that will show us the detail. And looking at this detail shows us that there's been a shell shock CVE attack coming from North Korea. One of the real benefits of this integration with QRadar is that you can very easily look at other events that are related that are surrounding a certain event. So for example, we can open up the Cisco dashboard and now we can look at all the Cisco events that were happening around the same time concerning that same IP address, even when these events weren't part of the original offense that we were investigating in QRadar. And the search isn't restricted to just network events. For example, we can open up the Windows dashboard and we can then look at data around that same time, all Windows servers and usernames and the surrounding activity.